Welcome back, class, to section 8.2, solving equations by factoring ax squared plus bx plus c. Here's explained 2a. Change the quadratic equation to standard form, if necessary, and then solve by factoring. Just a few reminders, standard form is the same thing as trinomial form. So the equation needs to be in trinomial form, which is ax squared plus bx plus c, and we want to take that and set it equal to 0. Unfortunately, what we have is not in trinomial form. Let's go ahead and rewrite this equation so that it is in trinomial form. So I want to move the 8v to the other side. That's going to give me 8v squared minus 8v equals 6. I moved the 8v instead of the 8v squared because I want to try to keep my leading coefficient positive. Now let's subtract 6 to both sides. And that's going to give us 8v squared minus 8v minus 6 equals 0. Notice how I didn't combine the 8v squared minus 8v. That's not a coincidence. That's because they're not like terms. The first 8v has an exponent of 2, whereas the second 8v does not have an exponent. Okay, it has an imaginary exponent of 1. So they're not like terms. Let's keep going. So we have 8v squared minus 8v minus 6 equals 0. Notice how all three numbers are divisible by 2. To make this equation a little easier to solve, let's divide everything by 2. Eight divided by 2 is 4. 8 divided by 2 again is 4. And negative 6 divided by 2 is negative 3. 0 divided by 2 is 0. So I changed the equation so that the numbers are easier to work with. Now let's identify a, b, and c. A is 4, b is negative 4, c is negative 3. Class, let's draw our x. We're going to put a and c at the top, b at the bottom. 4 times negative 3 is negative 12, and at the bottom we have negative 4. Now go ahead and think of two numbers that will multiply to negative 12, but will add up to negative 4. I'll give you a few seconds. Perfect. So the two numbers that will multiply to negative 12, but will add up to negative 4, are negative 6 and 2. Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. Now let's divide those numbers by a. And a is 4. Let's reduce to fractions. Negative 6 and 4 are both divisible by 2. Negative 6 divided by 2 is negative 3. And 4 divided by 2 is 2. Let's put our variable at the bottom. We no longer have x's, we have v's instead, which is okay. If you feel comfortable with x, go ahead and write x. We also have 2/4. 2 and 4 are both divisible by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. Write the variable, and we're almost done. So now that we have our fractions, let's write out our factors. The factors are 2v minus 3 and 2v plus 1. Set it equal to 0. Let's use the zero product property to solve. Set each factor equal to 0. In our first equation, we want to add 3 to both sides. That's going to give us 2v equals 3. Divide by 2. V equals 3/2. In our second equation, we want to subtract 1 to both sides. We get 2v equals negative 1. divide by 2, v equals -1/2. So those are our solutions. Let's check our work. I'll go ahead and check v equals -1/2. When you check your work, you want to go back to the original equation just in case you made a mistake somewhere in between. So when v equals -1/2, we have, let's plug that in. 8 times -1/2 squared is equal to 8 times -1/2 plus 6. -1/2 squared is 1/4. And 8 times -1/2, that's going to give me -4 plus 6. 8 times 1/4 is 2, and -4 plus 6 is 2. So 2 equals 2, and that checks, which means that -1/2 is a solution. Now let's check 3/2. So I'm just going to fast forward the clip. With the power of editing this video, we are now going to check v equals 3/2. So I'm taking the 3/2 and I'm plugging it back into my original equation. That's 8 times 3/2 squared is equal to 8 times 3/2 plus 6. 3/2 squared is 9/4, which equals 8 times 3/2, which is 24/2, plus 6. Okay, class, 8 times 9/4. I'll go ahead and simplify this. I know I can cancel out 4 and 8. 4 divided by 4 is 1. 8 divided by 4 is 2. So 2 times 9 is 18. 24 divided by 2 is 12, and that's 12 plus 6. 18 equals 12 plus 6 is 18, and notice how it checks. 18 equals 18, which means that v equals 3/2 is a solution. Let's do one more problem. Explain 2b. Change the quadratic equation to standard form if necessary, and then solve by factoring. So like I said, we want to rewrite this in trinomial form. We want to make sure that the equation is equal to 0. And in this case, it's not. So let's go ahead and rewrite it. I want to keep my leading coefficient positive, so instead of subtracting the 4x squared to both sides, I'll go ahead and subtract the 2x squared to both sides. So I'm subtracting 2x squared to both sides, and now I have 7x minus 2 equals 2x squared plus 4. Okay, let's subtract the 7x to both sides, and that's going to give us -2 is equal to 2x squared minus 7x plus 4. Don't combine the 2x squared with the 7x because they're not like terms. So now we want to add 2 to both sides. And that's finally going to give me 0 is equal to 2x squared minus 7x plus 4 plus 2 is 6. So now that our equation is finally equal to 0, let's go ahead and identify a, b, and c. A is 2, b is -7, and c is next. Let's draw our x. At the top, we're going to put a and c, and at the bottom, we're putting b. 2 times 6 is 12. -7 is going to go at the bottom. Class, I want you to think of two numbers that'll multiply to 12, but will add up to -7. Go ahead and take a second to think of the two numbers. Great. The two numbers are -4 and -3. -4 times -3 is +12, and -4 plus -3 is -7. Now take those numbers and divide by a. A is 2. Reduce the fractions. -4 and 2 are both divisible by 2. -4 divided by 2 is -2. 2 divided by 2 is 1. Write the x at the bottom. And now we have -3/2, which we can't reduce, so we'll leave that as is. Okay, class, now let's write out the factors from the bottom up. we have x minus 2 times 2x minus 3 equals 0. Go ahead and use the zero product property. Set each factor equal to 0. X minus 2 equals 0, and 2x minus 3 equals 0. In our first equation, we want to add 2 to both sides. X equals 2. In our second equation, let's add 3 to both sides. We get 2x equals 3. Divide by 2, x equals 3 halves. And so x equals 2 and x equals 3 halves are our solutions. And if you want to check your work, all you need to do is plug them into the original equation. In fact, let's go ahead and check. So when you check your work, make sure you go back to the original equation. And the original equation is 2x squared plus 7x minus 2 equals 4x squared plus 4. Take the 2, plug it in. So it's 2 times 2 squared plus 7 times 2 minus 2, which equals 4 times 2 squared plus 4. That's 2 times 4 plus 7 times 2 is 14 minus 2, which equals 4 times 2 squared is 4. 2 times 4 is 8 plus 14 minus 2 equals 4 times 4 is 16 plus 4. 8 plus 4 is 22 minus 2 equals 16 plus 4 is 20. 22 minus 2 is 20, and 20 equals 20. So it checks. X equals 2 is a solution. Now let's fast forward this clip and check x equals 3 halves. And we're taking the 3 halves and plugging it into our equation. So 2 times 3 halves squared plus 7 times 3 halves minus 2, which equals 4 times 3 halves squared plus 4. So that's 2 times 3 halves squared is 9/4 plus 7 times 3 halves is 21 halves minus 2, which equals 4 times 3 halves squared is 9/4 plus 4. 2 times 9/4 is 18/4 plus 21 over 2 minus 2, which equals 36 over 4 plus 4. So now I want my denominators to be the same. If you look at the left-hand side of the equation, notice how we can't combine 18/4 with 21 halves. So let's go ahead and rewrite the 18/4 so that it has a denominator of 2. So the 18 over 4, you can reduce that to 9 halves plus 21 halves minus 2 equals, and we have 36 over 4. Let's go ahead and divide 36 and 4. That's going to give us 9 plus 4. Okay, class, so 9 halves plus 21 halves is 30 halves minus 2 equals 9 plus 4 is 13. And finally, 30 halves is 15. And that's 15 minus 2, and it's supposed to equal 13. And since I ran out of space, let me continue my work here. 15 minus 2 is 13, and 13 equals 13, so it checks, which means that 3 halves is also a solution. That concludes our video. If you like this video, go ahead and give it a thumbs up, and don't forget to subscribe.